Good morning to all. Electrical machine design of field winding, design of shunt field winding. Problem: a shunt field coil has to develop an mmf 9000 A. The voltage drop of coil is 40 volts and the resistivity of round wire used 0.0212 meter and millimeter square. The depth of winding 35 millimeter approximately and the length mean turn is 1.4 meter. Design a coil so that the power dissipated is 700 watts per meter square of the total coil surface. Take the diameter of insulator wire 0.2 millimeter greater than that of bare wire. In this problem, given values are VSH is equal to 40 volt, that is shunt field voltage drop of coil. LMTF, length of mean turn, is equal to 1.4 meter. ATF is equal to 9000 mmf. DF is equal to 0.035 meter, that is 35 millimeter depth of winding. PF is equal to 700 watts per meter square. Is the loss as the field system per a unit cooling surface. Solution: ASH, cross-sectional area of shunt field winding. ASH formula is rho LMTF into bracket of ISH into TSH divided by VSH. Rho is equal to 2 into 10 power minus 8. In problem, amplitude is given. ASH is equal to rho LMTF into ISH into TSH divided by VSH. Continuation of solution. ASH is equal to 2 into 10 power minus 8 into 1.4 into 9000 by 40. Above formula put required values. Find ASH value is equal to 6.3 into 10 power minus 6 meter square, that is 6.3 millimeter square. ATF is equal to ISH into TSH, that is 9000. Continuation of solution. HF is equal to ATF divided by ATF dash is equal to 9000 divided by 39906.14. ATF dash is equal to 10 power 4 root of SFDF or PF. ASH is equal to pi by 4 D square. From this formula we obtain D value 2.8 millimeter. HF is equal to ATF divided by ATF dash. Put required values, you find HF value is equal to 0.W25 meter. ATF dash is equal to 10 power 4 root of SFDF PF. Put required values, you find ATF dash is equal to 39906.14. Continuation of solution. SF is equal to 0.75 bracket of D divided by DA whole square. DA is equal to 2.8 plus 0.2, that is equal to 3 given. SF is equal to 0.75 bracket of 2.8 divided by 3 bracket square. DA is equal to diameter of insulated conductor. SF is equal to 0.65. ATF is equal to 9000. ATF dash is equal to 39906.14. Solution. Continuation. HF formula we explained in theory classes. HF is equal to ATF divided by ATF dash. HF is equal to 0.W25 meter. That is second solution. Cooling surface formula is 2 into mean length of turn into height of the coil plus depth of the winding. 2 into LMTF into bracket of HF plus DF bracket of meter square. Continuation of solution. Cooling surface is equal to 2 into LMTF and bracket of HF plus DF. 2 into 1.4 into 0.235 plus 0.035 is equal to 0.728 meters square, that is cooling surface. Permissible loss in watts is equal to permissible loss in watts per meter square into cooling surface in meter square, that is 700 into 0.728 is equal to 509.6 watts. Continuation of solution. Shunt field current ISH is equal to permissible loss in watts divided by VSH. I shunt is equal to 509.6 divided by 40 is equal to 12.74 A ampere. TSH is equal to total number of turns is equal to ampere turns divided by ISH. ATS divided by ISH is equal to 9000 divided by 12.74. That is TSH value is equal to 706.4. That is TSH equal to 706 turns. TSH value is 706 turns. RSH formula is rho LMTF TSH divided by ASH. ISH is equal to 12.74 turns. TSH is equal to 706. ASH is equal to 6.3 millimeter square, that is 6.3 10 power minus 6 meter square. RSH is equal to rho LMTF TSH divided by ASH. RSH is the resistance of shunt field winding. Put required values in formula, we obtain RSH value. RSH is equal to 3.13 ohm. Shunt field copper loss formula is equal to ISH square into RSH. 12.74 square into 3.13. Copper loss. Shunt field copper loss is equal to 508.02 watts. That is the answer. Good morning to all. Electrical machine design of field winding, design of shunt field winding. Problem 2. Question: 6 pole 440 volts, ampere turns per pole, 7,200, mean length of turn 1.2 meter, depth of winding 3.5 centimeter, permissible loss 650 watts per meter square. The diameter of insulator conductor is 0.175 millimeter, greater than that of bare conductor. Design the shunt field winding for this. Assume a voltage drop of 50% across the field regulator. I already asked my theoretical class VSH formula VSH is equal to 0.8 to 0.85 V divided by P for generator, and VSH is equal to V divided by P for motor. In this questions given supply voltage is 440 volts and assume a voltage drop of 50% across the field regulator mentioned in questions. So we obtain VSS is equal to 0.85 V divided by P is equal to 0.85 into 440 divided by 6. Given value V is equal to 440, pole value P is equal to 6. VSH is equal to 62.33. Continuation of solutions given. Value V is equal to 440 volt, pole value P is equal to 6 pole, ampere turns per pole is equal to 7,200, that is ATF, mean length of turn is equal to 1.2 meter, that is LMTF, depth of winding 3.5 centimeter, that is DF, permissible loss is equal to 650 watts per meter square, that is PF, diameter of conductor is 0.17 millimeter, greater than that of bare conductor, that is DA greater than 0.175 millimeter. Design shunt field winding, voltage drop is equal to 50% of field regulator. That is given values. Continuation of solution. VSH is equal to 0.85 V divided by P. VSH is equal to 62.33. ASH cross sectional area of shunt field winding. ASH rho LMTF into bracket of ISH into TSH divided by VSH. Rho is equal to 2 into 10 power minus 8. LMTF is equal to 1.2. ATF is equal to ISH DSH, that is 7,200. VSH value is equal to 62.33, that is find out value. Continuation of solutions. ASH is that is area is equal to rho LMTF into ISH into TSH divided by VSH. 2 into 10 power minus 8 into 1.2 into 7,200 by 62.33. ASH values we obtain 2.77 millimeter square. We already have spent theoretical classes. SF formula is 0.75 into d by df bracket of whole square. ASH is equal to pi by 4 d square. From this formula, ASH formula, we obtain d value. D is 1.878 meter. Diameter is greater than 0.175. That is given in question. DA is equal to d plus 0.175. So 1.875 plus 0.175. DA is equal to 2.053. Put d value in ASH formula. We find put ASH value in ASH formula, we obtain d value. From this value, DA value obtained. SF is equal to 0.75 into d by dA bracket square. Put required values, we obtain SF value. Continuation of solutions. Third solution. HF is equal to ATF divided by ATF dash. SF value is 0.6. We obtain ATF dash is equal to 10 power 4 root of SF DF PF. Put required values, we obtain the ATF dash is equal to 39357. ATF value we already given 7,200. Continuation of solution. HF is equal to ATF divided by ATF dash. Put required values, we obtain HF is equal to 0.193 meter. Cooling surface formula 2 into mean length of turn into height of the coil plus depth of winding. 2 into LMTF into bracket of HF plus DF bracket meter square. Continuation of solution. Cooling surface is equal to 2 into 1.2 into HF plus DF. Put required values, we obtain cooling surface equal to 0.5232. HF is 0.193 meter. DF is 3.5 centimeter. That is 0.035 meter. Permissible loss in watts is equal to permissible loss in watts divided by meter square into cooling surface. 650 into 0.5332. Permissible loss in watts 346.45 watts. Continuation of solution. Shunt field current ISH is equal to permissible loss in watts divided by VSH. I shunt is equal to 346.445 divided by 62.33. I shunt is equal to 5.56 ampere. TSH is equal to total number of turns is equal to ampere turns divided by ISH. TSH is equal to ATS divided by ISH. TSH is equal to 1295 turns. RSH is equal to rho LMTF TSH divided by ASH. Given values: ISH is equal to 5.56, TSH is equal to 1295, ASH is equal to 2.77 into 10 power minus 6 meters square. Put required values. We have the resistance of shunt field when in RSH values. Continuation of solution: RSH is equal to rho LMTF TSH divided by ASH. Put required values. We obtain RSH is equal to 11.22 ohm. Rho is 2 into 10 power minus 8. LMTF is 1.2. Continuation of solution: shunt field copper loss formula is ISH squared into RSH. ISH is equal to 5.56 ampere. RSH is equal to 11.22 ohm. Shunt field copper loss. Put required values. We obtain 346.85 watts. That is answer.